Let's do this again. Z to the 2/3 plus 2z to the 1/3 minus 3 equals 0. This time it's not so obvious, but if we let u be this z to the 1/3, that means u squared would be z to the 1/3 squared, which is z to the 2/3, and that's what we have here. So this is u squared plus 2u minus 3 equals 0. And again, we can solve this. We can factor this. We need numbers that multiply to -3, that add to +2. These numbers are +3 and -1. U minus 3, sorry, u plus 3. I was getting ahead of myself. U minus 1, which means u plus 3 equals 0. U minus 1 equals 0. U equals -3, u equals +1. But we're not done. These are u's. U is z to the 1/3. Z to the 1/3 equals -3. Z to the 1/3 equals +1. How do we solve these? Cube both sides, because cubing the 1/3 power cancels them out. 3/3 is 1. -3 to the 3rd is -27. So z is -27. 1 to the 3rd is 1. Z is 1. -27 and 1 would be the answers. So for solving a quadratic equation, if the equation is in the form ax plus b squared equals c, use the square root property to solve. If not, write the equation in standard form, try to solve by factoring, and if that's not possible, use the quadratic formula. So let's solve the following equation. X minus radical 2x equals 4. We need to isolate the radical and square both sides. Subtract x from both sides. 4 minus x equals negative radical 2x. Divide both sides by -1. Radical 2x equals -4 plus x, which is x minus 4. So x minus 4 equals radical 2x. When we square both sides, we need to be careful to square x minus 4 as a binomial. FOIL it with itself or use the special formula. On the left, we're going to get x squared minus 8x plus 16. On the right, the radicals squared cancel each other out, leaving us with just 2x. Get everything on one side and 0 on the other, so subtract 2x from both sides. -8x minus 2x is -10x. Are there numbers that multiply to +16 that add to -10? Yes. -8 and -2. So this factors to x minus 8 times x minus 2. That means our solutions are x equals 8 and x equals 2, because we take each factor, set it equal to 0, and solve. X minus 8 equals 0 gave us the x equals 8. X minus 2 equals 0 gives us the x equals 2. Now we substitute the values for x back into the original equation. When we go to check 8, 8 minus the square root of 2 times 8, 8 minus the square root of 16, 8 minus 4 equals 4. That's a true state. When we check 2, 2 minus the square root of 2 times 2 equals 4. That's 2 times 2, 4. Square root of 4 is 2. 2 minus 2 is 0. 0 does not equal 4. This is a false statement. So the 2 doesn't check, but the 8 checks. The solution is x equals 8. So this presented as a radical equation, but we actually needed to solve it using quadratic methods by using factoring. This one is presenting as a rational equation. The LCD is x minus 2 times x plus 2. We multiply both sides by x minus 2 times x plus 2. On the right, that just gives us x minus 2 times x plus 2. On the left, we distribute the pair of binomials. The x minus 2 cancels in the first term, leaving us with 5 times x plus 2. The x plus 2 cancels in the second term, leaving us with 4 times x minus 2. When we distribute the 5 and the 4 on the left, 5x plus 10 plus 4x minus 8 equals x squared minus 4, what we get when we FOIL those or use the special formula. Combining like terms on the left, 5x plus 4x is 9x. Positive 10 minus 8 is positive 2. So 9x plus 2 equals x minus 4. Everything on one side, 0 on the other. The x squared is already positive on the right, so let's take everything to the right, subtract 9x, subtract 2. Negative 4 minus 2 is negative 6. So x squared minus 9x minus 6. Are there numbers that multiply to negative 6 that add to negative 9? No. We can't factor it, so we have to use the quadratic formula. We also could complete the square if we wanted to. We'll get the same answers. Maybe make that an exercise. Plug in the values. Get 81 plus 24 under the radical. That's radical 105. Now we have to substitute these back in to the original equation. Be very careful. I'm leaving this check as an exercise to see how you do with the arithmetic. Slowly going through the solution. So the plus checks. The minus checks. Now, I'll be honest. Do I really expect you to check something this complicated? No, probably just hope for the best. And in this case, the best happened. They both worked. When both values gave true statements, that means the plus or minus stays in the solution. 9x to the fourth plus 5x squared minus 4 equals 0. Now for this one, if this was x squared and x instead of x to the fourth and x squared, we'd be able to use quadratic methods to solve it. So let's pick a variable, any variable. How about w? And let w equal x squared. Then this is 9w squared plus 5w minus 4. Let's solve for w. Can we factor using the AC method? 9 times negative 4 is negative 36. Are there numbers that multiply to negative 36 that add to positive 5? Yes, there are. What are they? That's the question. So what are the factors of negative 36? And we need 1 plus 1 minus, probably. Yep, to multiply to a negative. Negative 36 and 1. Nope, that would be negative 35. Negative 18 and 2, that would be negative 16. We need positive 5. Negative 12 and 3. That would be negative 9. Negative 9 and 4. That's negative 5. So how about 9 and negative 4? 9 and negative 4, which was right in our face the entire time, does give us positive 5. So rewrite the 5w as 9w minus 4w, factor by grouping, and we get 9w minus 4 times w plus 1. I leave the factoring as an exercise if you didn't follow along with what I was saying. I also skipped all the important last steps. So 9w minus 4 equals 0. W minus 1 equals, or w plus 1 equals 0. But this wasn't about w originally. This was about x originally, and w is x squared. So we can substitute back in 9x squared minus 4, x squared plus 1. And then we notice it can factor further. 9x squared minus 4 is 3x plus 2 times 3x minus 2, or 3x minus 2 times 3x plus 2. It's a difference of squares. So 3x minus 2 equals 0, or 3x plus 2 equals 0, or x squared plus 1 equals 0. Solving, we get positive 2/3, we get negative 2/3, and x squared equals negative 1. That's the square root of negative 1 plus or minus the square root of negative 1, which is plus or minus I. That's 4 possible answers, and we check. The positive 2/3 works. The positive I works. The negative 2/3 works. And the negative I works. Again, I'd expect you to just hope for the best. I wouldn't expect you to check these. But we have 4 solutions. Next up, 3x to the 2/3 plus 11x to the 1/3 equals 4. If this was just x squared and x, we'd be able to use quadratic methods to solve. So let's use w again. Let's let w be x to the 1/3. That makes this 3w squared plus 11w minus 4 equals 0, because we have to move that 4 from the right to the left, subtract 4 from both sides. Using the AC method, are there numbers that multiply to -12 that add to 11? Positive 12 and -1. So make that plus 11w into plus 12w minus w. Factor by grouping. And we get 3w minus 1 times w plus 4. 3w minus 1 is actually 3x to the 1/3 minus 1. W plus 4 is actually x to the 1/3 plus 4. We substitute back. Set both of those equal to 0. 3x to the 1/3 equals 1. X to the 1/3 equals 1/3. Cube both sides to undo the cube root. And 1/3 cubed is 1/27. The other equation, x to the 1/3 equals -4. Cube both sides to get rid of the cube root. -4 cubed is -64. If we substitute 1/27 back into the original, it checks. If we sub -64 back into the original, it checks. So our two solutions work. Again, I wouldn't blame you if you just hoped for the best. Together, an experienced word processor and an apprentice word processor can create a document in 6 hours. Alone, the experienced word processor can process the document 2 hours faster than the apprentice. Find the time in which each person can create the document alone. So let's let x be the time in hours that it takes the apprentice. Let x minus 2 then be the time in hours it takes the experienced word processor, because they can do it 2 hours faster. That's some time minus 2. Remember the setup for a work problem. Part of job completed in 1 hour is what we're interested in. So if it's x hours total, that's 1x in 1 hour. If it's x minus 2 hours total, that's 1x minus 2th in 1 hour. And if it's 6 total hours for them to do it together, then in 1 hour, they get 1/6 of the job done. Part plus part equals whole. 1 over x plus 1 over x minus 2 equals 1/6. The LCD is 6x times x minus 2. Distributing on the left. In the first term, the x's cancel, leaving us with 6 times x minus 2. In the second term, the x minus 2's cancel, leaving us with plus 6x. On the right, the 6's cancel, leaving us with x times x minus 2. Distributing to get rid of the parentheses. Moving everything to the right side. 6x plus 6x is 12x, so subtract 12x. Add 12. We get x squared minus 14x plus 12. Are there numbers that multiply to 12 that add to negative 14? Nope. So quadratic formula. I know I'm going through this relatively fast. Feel free to pause and slow down, work through it on your own if you want. These problems are great practice on everything we've done. We use the quadratic formula. We get our two answers. We get our answer. X was 13.1. The reason we don't do anything with the 0.9 is because the other guy can do it 2 hours faster, or the other girl. And if we subtract 2 from 0.9, we get a negative time. We can't have a negative time. So 13.1 hours is the slower time for the apprentice. 2 hours faster is 11.1 hours. For the experienced word processor. Beach and Fargo are about 400 miles apart. A salesperson travels from Fargo to Beach one day at a certain speed. She returns to Fargo the next day and drives 10 miles per hour faster. Her total time was 14 2/3 hours. Find her speed to Beach and the return speed to Fargo. Now we have this diagram. They're 400 miles apart. Going to Beach was X miles per hour, and it was faster going to Fargo by 10 miles per hour, X plus 10 miles per hour. We know distance equals rate times time. The distances are the same. The distance doesn't change. So the rate times time one way has to equal the rate times time the other way. How do we find the time? Well, distance equals rate times time. We know distance is 400. We know the rate is X. So distance divided by rate. 400 divided by X gives us time. So to Beach, the time was 400 over X. Again, the return to Fargo, the distance was 400, the rate was X plus 10, so the time is distance divided by rate, 400 divided by X plus 10. So the time to beach plus the return time to Fargo, we're told was 14 2/3 hours. 14 2/3 is 44 thirds. This is a direct translation of what we're told. Her total time was 14 2/3 hours. That's both legs of the trip. So we solve. The LCD is 3 times x plus 10. Before we get to that, we can divide everything by 4. The 400s become 100s. The 44 becomes 11. Now we multiply by the LCD, the 3 times x plus 10. Distribute the 3x times x plus 10 to both terms on the left. Multiply it by the 11 thirds on the right. On the right, the 3's cancel, leaving us with 11x times x plus 10, which is 11x squared plus 110x. The left has been simplifying as we go. $600x plus 3,000. Subtract 600x from both sides, subtract 3,000 from both sides. We get 11x squared minus 490x minus 3,000. This does factor, but there is absolutely no way that I'd expect you to factor it. This is what the quadratic formula is made for. But you'll get the same answers. The speed's not negative, so it's not our negative 5 5/11, but the number 50 does check. So do the quadratic formula, see if you can get 50 and negative 5 5/11. If you can, then you can say that you did the problem that showed that the speed to beach was 50 miles per hour and the return speed to Fargo was 60 miles per hour. So I know in this topic I went through a lot, but really this kind of acts as a review of everything that we've done so far. So I'm leaving a lot of the minutia up to you for practice. That's it for this topic. We want to write in terms of I, we have the square root of -9. -9 can be rewritten as -1 times 9. We can split that radical up so that it's the square root of -1 times the square root of 9. The square root of -1 is what we define as I. The square root of 9 is 3, so I times 3 is just 3I. Number 12. We want to perform the indicated operation and write the result in the form A plus BI. That means we need to split it up. We can't leave it as one fraction when we do our work. So we're starting with 7/5 plus I. And just like when we were conjugating or taking the conjugate so that we could rationalize the denominator of that previous problem, the conjugate of 5 plus I is 5 minus I. Multiply by 5 minus I over 5 minus I, a form of 1, so we don't change the value. That's distribution on the top. 7 times 5 minus I would be 35 minus 7I. On the bottom, we have 5 plus I times 5 minus I. Again, that sets up a difference of squares. 5 squared minus I squared. 5 squared is 25, minus I squared is defined as -1. 25 minus -1 is 25 plus 1, so we have 35 minus 7I over 26. We must split that up. 35 over 26 minus 7 over 26I. Number 13. Find the power of I. We have I to the 59th. And the key to this problem is realizing that I to the 4th power is 1. And therefore, any multiple of 4 power of I is 1. So we want to find the multiple of 4 power. That's the highest one that goes into 59. That's 56. 59 is 56 plus 3. 56th power of I would be I to the 4th times 14. 4 times 14, I to the 4th to the 14th power. I to the 4th is 1. 1 to the 14th is 1. So we have 1 times I cubed, which is just I cubed, which is I to the 2 plus 1, which is I squared times I, which is -1 times I, which is -I. Number 14, use the square root property to solve the equation. We have x plus 10 squared equals -25. Square root property says once we have a square by itself, square root both sides. We do have a square by itself, so we square root both sides. The square root of the square of x plus 10 is just x plus 10. The square root of -25 would be plus or minus 5i. Subtracting 10 over so we get the x by itself, we get x equals -10 plus or minus 5i. So -10 minus 5i and -10 plus 5i. Number 15, add the proper constant to the binomial so that the resulting trinomial is a perfect square trinomial. Then factor the trinomial. So here we're completing the square. We take half of the number in front of x and then square it. So the constant term here is going to be half of +6 squared. So the constant term is +3 squared. And the constant term would be 9. 3 squared is 9. Half of 6 is 3. 3 squared is 9. And that factors to x plus 3 squared. The answer here in this order is B. Number 16. Solve the equation by completing the square. We have x squared plus 14x plus 34 equals 0. We're going to start by moving the constant term over to the other side. X squared plus 14x equals -34. Half of 14 is 7. 7 squared is 49. We add 49 to the left, but that means we also have to add 49 to the right. This factors to x plus 7 squared. And -34 plus 49, it's the same as 49 minus 34. That'd be 15. So x plus 7 squared equals 15. We have a square. on one side by itself, so we take the square root of both sides. The square root of the square just leaves us with x plus 7 on the left. Taking the square root of 15, we have to be careful to write plus or minus radical 15. Finally, subtract 7 over to get rid of the plus 7 and get x by itself. We get x equals -7 plus or minus 15. So -7 minus radical 15, -7 plus radical 15. That's -7 plus or minus radical 15. I think I might have just said 15. Number 17. Use the quadratic formula to solve the equation. 5x squared plus 12x equals -6. Get everything on one side, 0 on the other to identify A, B, and C. We have a -6 on the right. We add 6 to both sides, giving us 5x squared plus 12x plus 6 equals 0. A is 5. B is positive 12. C is positive 6. And we plug that into the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we have the opposite of 12 plus or minus the square root of 12 squared minus 4 times 5 times 6 all over 2 times 5. That's -12 plus or minus the square root of 12 squared is 144. Minus 4 times 5 times 6 is 120. 144 minus 120 is 24. So we have -12 plus or minus the square root of 24 all over 10. We need to simplify that radical, though. 24 is 4 times 6. So that's the square root of 4 times the square root of 6, or 2 square root of 6. Now we can factor a 2 out of the top, leaving us with -6 plus or minus radical 6. We can factor a 2 out of the bottom. 10 gets rewritten as 2 times 5. The 2's cancel, just leaving us with -6 plus or minus radical 6 all over 5. So -6 minus the square root of 6 over 5, -6 plus the square root of 6 over 5. Finally, number 18. We want to solve x to the 2/3 minus 5x to the 1/3 plus 4 equals 0. And we can make a u substitution. If we let u equal x to the 1/3, then this gets rewritten as u squared minus 5u plus 4 equals 0. That factors to u minus 1 times u minus 4 equals 0, which gives us answers for u of 1 and 4. But 1 and 4 is not the answer. Those are u's. We want x's. So x to the 1/3 equals 1. X to the 1/3 equals 4. Cube both sides for each equation. We get 1 cubed and 4 cubed, which would be x equals 1 and x equals 64. That's that.